Good afternoon, everyone. So today we will be discussing the solutions and colloids in your chapter 5. Okay, so since we cannot discuss this face to face, this will serve as your reference for your examination for this topic. Okay, so let's have here a brief introduction of mixtures. Mixtures consist of two or more components which are not chemically bonded. Please take note that it's not chemically bonded, and they are categorized as we all know the homogeneous and the heterogeneous mixtures. These are based in the uniformity of composition. Okay, so i-expound natin later on what is a homogeneous mixture and a heterogeneous mixture. So sabi niya dito, the lesson also explores the fundamental concepts of mixtures, their types and characteristics, providing a foundation for understanding solutions, colloids, and suspensions used in various scientific and industrial applications. Okay? I think hindi pwedeng magsulat dito. Ayan. So, we have here the two types of mixtures class. The first type is the homogeneous mixture. Take note that when we say homogeneous mixtures, these mixtures have a uniform composition throughout. Ibig sabihin class, when we mix a, what do you call this one, something to something, it will be uniformly distributed. Take note that they are indistinguishable. So when we say indistinguishable class, you cannot identify the individual substances or individual thing that you have mixed in a certain solution. Let's say for example, when we mixed a coffee in a water, when you stir it, it will be uniformly distributed. Okay? Paano mo sabi na uniformly distributed is that hindi mo na ma-identify, you cannot distinguish anymore which is coffee and which is the water. Okay? Because you can see the water itself but you cannot see anymore the coffee. Ayan. So, let's have here heterogeneous mixture naman. When we say heterogeneous mixture class, these are mixtures that do not have uniform composition. When we say it doesn't have uniform composition, take note. Let's say for example, we have pinakbet. Okay, when we cook pinakbet, when we mix the different veggies, what will happen is that you can still distinguish them. That's why it's not uniform in composition. Hindi mo pwedeng pinakbet, isa lang ang makikita mo. Hindi pwedeng sasabihin mo, ang nakita mo lang dun is solo talong. Okay? Naging talong ba lahat yung mga veggies na nilagay mo? No. Because it's a heterogeneous mixture. Sabi niya dito, the substances are not evenly distributed and are easily distinguishable. At ito pa, malapit ng Pasko for the macaroni salad or any salad that you want to make on Christmas or in New Year. Diba? We can have macaroni salad. We can distinguish which are the given the things that you are going to mix with the macaroni pasta, right? That's why heterogeneous mixtures class, they are highly distinguishable. They do not have uniform composition. Now let's identify if the following is a homogeneous or heterogeneous mixtures. First is salt water. Take note that when we say salt water class, it is what do you call this one? It is salt water, nagiging uniform po yan. It means that it is a homogeneous mixture. When we say coffee naman, nagtimpla ka ng coffee, nilagyan mo ng asukal, kaya nagtimpla ka, meron kang creamer. Meron ba? Nakikita mo ba ang solo creamer doon? Hindi po. Nakikita mo ba ang individual identity ng nilagay mong mga ng kape, ng asukal at creamer? No. Okay, so what you consider is a uniform coffee. That's why it is called homogeneous mixture. How about salad? Yung example ko kanina, example, fruit salad. You were able to distinguish what are the fruits that you have mixed in the fruit salad that you are going to make, right? So madi-distinguish mo since it is called now as a heterogeneous mixture. Hetero, halo-halo, at nakikita mo yung pagkakaiba nila. How about open soda drinks? Of course, this open soda drinks example class, yung Coke. Sa Coke ba nakikita mo kung may sugar yun? Yes, pero sa doon lang po sa cover niya. But in the solution itself class, we cannot identify the individual substances or individual things that is being mixed with this soda. Ibig sabihin, it's a homogeneous mixture. How about gravel and sand? Of course, ang gravel and sand, pinaghiwalay na nga yan. Gravel and sand class, hindi po sila magmi-mixed together. I mean, hindi po sila magkakaroon ng uniform characteristic. Okay? Ibig sabihin, madidistinguish mo which is gravel. You can also distinguish which is sand. Now, let's proceed to solutions, colloids, and suspensions. Let's start with solutions. Solutions class are homogeneous mixtures with very small particles. And take note that they do not settle and they do not scatter light. Tandaan po natin yan. Ang solution, hindi po sila nagsisettle dun sa baba. Ibig sabihin, they are uniform mixtures with particles at the molecular level. And please take note, class, that solutions are very small. They are not visible even under a microscope and they do not show Tyndall effect. Ano nga ba itong Tyndall effect? Ang Tyndall effect po class, it can scatter light. Okay, tandaan po natin, they cannot be separated also by filtration. Ayan, sa example natin dito class, we have sodium chloride, we have sugar water. Okay, anyway class, ang ating solution class, it is also where a solute dissolves in a solvent. What does it mean, class? We have two parts kasi of a solution. We have a solute and we have a solvent. Question, class. Lahat ba ng solute kailangang solid? Example daw. Powdered juice. Ang powdered juice is a solute because it is solid. Kailangan bang solid lahat ang magiging solute natin? No. Hindi po lahat ng solute ay solid. Some are liquid, some are gases. So, we will be having a brief discussion later on the examples of those things. Ang solute, siya po yung it dissolves in a solvent. Okay? The one that is being dissolved in a solvent, while the component present in the larger amount is solvent. What is our universal solvent? Take note that it is water. Okay? So, let's say for example, yung nai-intake nating air. Is it a solution, class? Ang solution po is a mixture of solute and solvent. Okay? Ang air po, class, it's a mixture of gases, primarily the nitrogen and the oxygen. Ayan. So, here are the types of solutions. Paano mo nasabi, ma'am, na hindi lahat ng solute ay solid? At hindi lahat po ng solutions ay liquid. Some are solid, some are gases, some are liquid. Okay? So, let's start with gas in gas. Ang gas in gas solution class, yung hangin na nalalanghap natin. Di ba sabi nila, we breathe in oxygen. Do we only breathe in oxygen? Okay, kasama po sa binibreathe natin is nitrogen and other gases. So, nafi-filter lang po siya sa ating respiratory system. So, gas in gas po, class, ang solute natin, hindi po yan solid. Gas po ang ating solute. And our solvent is also a gas, forming an example of air that we breathe in. How about gas in liquid? Kayang-kaya ba na ang gas, class, is matunaw sa liquid? Yes, that is an example of a carbonated water or yung pop natin or the soda drink that we usually drink. Lalo na kapag sobrang lamig, 'di ba? Gustong-gusto natin yung mga ganong drinks, yung mga soda, Coke. Okay, kung mapapansin niyo, class, may carbon gas yun. Bakit? Bumubula-bula siya. Okay, that is why we can create carbonated water with the use of a gas, carbon gas, and dissolved in a liquid. How about liquid in liquid? Ayan. Ang solute daw natin is liquid. Example ng solute na liquid, yung alcohol. Sabihin na natin ang alcohol na gin, yung wine. Wine ba? Hindi. Liquor. Okay, sabihin na natin na ang alcohol class, alangan naman na iinumin mo ang alcohol ng 100%. Diyos ko, papakamatay. Okay? So, that alcohol must be diluted in order for people to to consume, right? In order for it to become what do you call this one? Consumable. Okay? So, kapag dinisolve mo po siya class, liquid alcohol to a liquid water class, forming now the alcoholic beverages. Okay, now let's proceed also in solid in liquid. Sabi niya dito, ang solid in liquid, this is the most common solutions that we knew. Bakit? Ayun, example, yung salt, tinunaw mo sa water, it will become salt water. Ang sugar na tinunaw mo sa water, it will become sugar water. Okay, how about solid in solid? Have you ever wondered why is it that sobrang tigas ng mga bakal ng barko, ng eroplano? Individual element po ba yan na metal ang nilagay? The answer is no. Ibig sabihin, class, when you mix two metals, the more stronger. Okay? The stronger the metal is. Okay, let's say for example, when we mix iron and nickel, okay, iron and nickel, nagkakaroon po tayo ng it's either brass, steel, or alloy. Those brass, steel, or alloy class are strong enough. They are stronger. Okay, they are stronger para hindi po sila agad mag-crash. Ayan. So, paano po ginagawa ang solid to solid class? Of course, paano ba ginagawa ang mga kutsilyo? Okay, ang ginagawa, minemelt po nila yan. Right? How about gas in solid? Ang gas in solid naman class, ito si hydrogen palladium. Okay, this is a, what they call this one, a deeper solution. Okay? A greater type of solution that is being used in chemistry. Okay? So, take note that this hydrogen in palladium naman class, when si hydrogen gas naman po, it comes into contact with palladium metal. Ibig sabihin, from gas, ma-dissolve siya ito solid. Kapag yung hydrogen gas class ay it came in contact with the palladium metal. Okay, take note that palladium is in your periodic table of elements class A. So it has the ability to dissolve and diffuse into metal lattice, and this forms now as the metallic solution or the interstitial solid solution of hydrogen in palladium. Okay? Next tayo, we have colloids. And so when we talk about colloids naman class, sabi dyan that colloids, tandaan, colloids have larger particles, okay, that remain dispersed and exhibit the Tyndall effect. Okay, tandaan po natin class that a colloid is a type of mixture in which one substance lang po is evenly distributed throughout another substance. Okay, these particles class are intermediate in size. Ibig sabihin, they are larger than those in solution, but they are smaller than those in a suspension. Okay? Tandaan po natin yan, they are heterogeneous microscopically. They, the colloids, they do not settle out class because they are small enough to remain suspended. Ano nga ba itong Tyndall effect, ma'am? And when we say Tyndall effect, ito po yung ini-exhibit ng isang colloid. Let's say, for example, ang colloid kasi class, it scatters light. It makes a beam visible when passed through the mixture. For example, nakakita na kayo ng fog. Yan, fog. Lalo na pag, excuse me, pag may nakikita, pag nasa Baguio kayo class. If you have seen a fog, try to light it. Okay? Mag-i-scatter po yung, ilawan nyo siya through a flashlight. Mag-i-scatter po yung light. Okay? Tandaan po natin yan. Okay. Now, let's have here, try nyo tong gawin, itong si milk. Tiny droplets of fat and protein dispersed in water. Try nyo siyang ilawan in a clear glass. Also, class, we have jelly or gelatin, a network of protein molecules dispersed in water, creating a semi-solid gel, and also si smoke. Si smoke, class, nagre-remain suspended po yung solid particles sa air. Kaya nakikita natin yung puti-puti na parang cloudy, at saka kung ang nasusunog class is goma, ganun, di ba? Medyo dark siya. Kasi those are solid particles that are suspended in air. Yan. Now, how about suspensions? Okay? So, when we say suspensions naman, class, they contain the largest particles that can settle out and scatter light. Tandaan nyo po, the larger the particles, the higher the tendency of scattering and light. Okay? They can settle out and they can scatter light. Take note also that suspensions class are heterogeneous mixture in which solid particles are dispersed in a liquid gas, but particles are large enough out over time if left undisturbed. Okay, the particle size in suspension is very big. Okay, making them visible to our naked eye. Okay, so please take note of those. Excuse me. Now, we have here an example, this example class. Wait lang. Okay. We have muddy water, the soil particles suspended in water. Nagsususpend lang po siya. The sand and water also, sand particles mixed in water. Okay, now what are the differences now between solutions, colloids, and suspension? Okay? Pag sinabi po, when it comes to particle size class, very small po ang solution. Kapag colloid naman class, intermediate lang po siya. Kapag suspension naman class, it is the largest among the three. Ang appearance po ng solution class, homogeneous po siya. Ibig sabihin, it is uniform throughout. Pag colloid naman, it appears homogeneous to the naked eye, but it is heterogeneous microscopically. Ibig sabihin, kapag nakikita mo siya, mukha siyang solution kasi uniform. But when you look into a microscope class, heterogeneous po siya. Na-identify mo po yung individual materials. Pag suspension naman po class, heterogeneous po yan. The particles visible or it settles up. Okay? So, the visibility of particles naman class, ang solution, it is not visible under a microscope, while colloid class, it is not visible to the naked eye, but it can also scatter light, which is known as the Tyndall effect. Okay? So, ang suspension naman class, sabi ko kanina, it is visible to the naked eye or in microscope. Okay? So, alin sa kanila ang pinaka nag-show ng Tyndall effect? Take note, the light scattering class sa solution, it does not show any Tyndall effect. Kapag sinabi namang colloids, it shows Tyndall effect but not in opaque mixtures. Pag sa suspension naman, it can show Tyndall effect but it is not stable. Ang solutions ulit, for the settling of particles, particles will never settle. Sa colloid naman, particles do not settle upon standing. Kapag sinabi naman pong suspension, the particles settle upon standing. Okay? So please take note of those things. Now let's proceed to the properties and factors. Ayan. So let's have here excuse me. Let's have here the solubility. Ano nga ba itong solubility class? Okay. Solubility is the maximum amount of solute that can dissolve in a solvent at a given temperature. Again, dito class na-apply na naman po ang ating KMT or the kinetic molecular theory. Sa solubility class, yung maximum amount of solute, it can dissolve in solvent at a given temperature. Ibig sabihin yan class, nahaapektuhan, the temperature affects the solubility of a solution or a solute in a solvent. Example, kapag nagtitimpla tayo ng Milo, o sabihin na lang natin gatas, pag malamig ang pinagtimplahan natin ng gatas class, hindi agad yan natutunaw. But when we mix it with a hot water, ang nangyayari class, nadidissolve po siya kaagad. Because, naapektuhan nga po siya ng temperatura. Okay? Now, solubility and its influencing factors. First is like dissolves like. Okay? Like dissolve like. Anong ibig sabihin nito, class? Is that this principle states that polar solutes, ano nga ba ang polar solutes, class? Polar solutes, class, these are compounds, these are mixtures that has a greater than or wait, let me confirm, baka may magkamali na naman ako sa polar. Yan. So, kapag sinabi natin non-polar, okay, pag sinabi natin non-polar, these are uneven distributions of, pag sinabi nating non-polar, it has an even distribution of electrons. So let's say for example, yung hydrogen gas, oxygen gas, 'di ba? Zero po ang kanilang electronegativity difference, or less than 0.5 po ang kanilang electronegativity difference. While polar naman po, it's greater than 0.5. Yeah, that's it. Now, let's have here temperature effects. Increasing temperature usually increases the solubility of a solid. Take note of that. Na kapag mataas daw ang temperature, of course, the solid in the solute, okay? Yung solute daw, mas mabilis siyang nadidissolve in a liquid because it increases the kinetic energy of the solvent, which has been discussed in your KMT or the kinetic molecular theory. Now, let's have here pressure effects. Okay? Under pressure affects the solubility of gases in liquids. Increasing pressure increases solubility. The more na nag-exert ka ng pressure in a solvent or in a solution, class, it increases the solubility of the solute. Okay? Now, let's proceed naman sa ating colligative properties. Under the colligative properties, class, these are properties of solutions that depend on the number of solute particles, not on the chemical identity of the solute. Di ba, meron tayong molarity, molality, and percentage composition. So, I'll be discussing those things later on. Okay? First, class, is boiling point elevation. What does it mean when we say boiling point elevation? So, when a non-volatile solute is added to a solution, the boiling point elevates. Okay. Paano po ito, class? Excuse me. Pag sinabi po kasi nating non-volatile solute, these are substances that do not easily evaporate. Hindi sila agad-agad nag-e-evaporate. Anong nangyayari, class? Example, yung tubig. 'Di ba? Kapag yung tubig, class, hindi mo tinaasan yung boiling, yung init niya, anong nangyayari? Hindi siya nag-evaporate. Pero kapag volatile material, let's say for example yung mga alcohol, ganyan, class, mabilis sila mag-evaporate yan. Okay, so when a non-volatile solute naman is added to a solvent, the boiling point of the solution increases compared to that of the pure solvent. Parang yung sa alcohol. Okay? Ang alcohol, when you mix an alcohol, it's not a non-volatile, okay? Ang non-volatile pa, it doesn't evaporate easily. Okay, example lang natin. When the solute, okay, the solute particles interfere with the escape of solvent molecules in the gas phase. Therefore, class, more energy is required in order, okay, to make the vapor pressure of the solution equal to the atmospheric pressure, which now will rise the boiling point. Okay? Now, let's give a more specific excuse me, example of this one. Okay? Yung when a non-volatile solute, ang non-volatile solute, diba, hindi siya agad nag-evaporate. Example, class, yung salt. Okay, si salt, dinagdag natin siya sa solvent, which is water. The boiling point now of the solutions becomes higher than that of the pure solvent. Okay, this happens because the solute particles make it harder doon sa liquid molecules to escape into vapor. Kasi ang water kasi class, nagiging vapor siya. So, more heat is added in order for boiling to occur. Ganun po yan. Okay? Next, vapor reduction. Vapor pressure reduction, adding a solute to a solution decreases the vapor pressure. Tandaan natin, let's say for example, when we add a solute to a solvent, it lowers the vapor pressure. Kapag dinagdagan po natin ang solvent ng isang solute class, it lowers the vapor pressure. Bakit? Because the solute particles will now occupy the surface space. Parang tatakpan niya yung surface ng solvent, preventing now the solvent molecules from escaping into the air. Ganun po yun. This means that the solution evaporates more slowly than the pure solvent. Di ba kung napapansin ninyo, kapag solo water lang pinapakuluan mo, class, is mabilis siyang kumulo. Pero pag nilagyan mo siya ng other material, medyo tumatagal. Kasi nga nagbabago po yung boiling point kapag dinagdagan mo ng solute ang isang solvent. Okay? Nagkaintindihan po ba? Ayan. Now, last one. Okay, hypertonic solution. A hypertonic saline solution helps reduce swelling by drawing water out of the cells into the bloodstream. Ano nga ba ang sinasabi nitong hypertonic? Pag sinasabing hypotonic, it's puputok. Okay, hypotonic, puputok. Pag hypertonic naman, mag-shrink po siya. Okay, example class. A hypertonic solution has a higher concentration of solutes. Ibig sabihin, class, mas mataas po yung solute niya kesa dun sa fluid doon sa loob ng isang cell. Example lang natin sa cell, kung na-discuss nyo na ito. Ibig sabihin nun, class, aalis po yung tubig out of the cell through osmosis, causing now the cell to shrink. Yung sinasabi ko sa inyo kanina. Okay? So, that's it. Example po natin dito sa hypertonic solution class is raisins in salt water. So when we soak a raisin in a strong salt solution, it shrivels as water leaves the raisin cells, demonstrating osmosis in a hypertonic environment. Okay? Parang, alam nyo yung raisin class, para siyang nagsisilbing cell na kapag nilagay mo siya sa sobrang taas ang salt solution or mataas ang salinity niya class, nagsishrink po siya, making naaalis po yung tubig dun sa loob niya. Okay? Next, the units of concentration, molarity, molality, and the percent composition. For the concentration class, 'di ba, kapag nagkakape tayo, we tend to concentrate more the solute. Let's say for example, in one cup of coffee, what are you going to put there is a 3-in-1, right? Yung 3-in-1, may sarili-sarili silang percentage composition yan. Okay? So, kung naalala nyo pa yung natin, yung start natin noon, that we have computed also the molarity, the molality, as well as the percentage composition. Lalong-lalo na yung percentage composition natin. Okay? Doon sa concentration class, it quantifies solute in solution and can be expressed as molarity. Pag molarity, it is under moles per liter. Pag molality naman, moles per kilogram of solvent. Kapag percent composition, this is the percentage mass by mass or volume. Take note of that. Okay? So, let's say for example, 35% is coffee, 40% is sugar, tapos, ilan na yun? 25, 35, 40, 75. Tapos, 25% yung creamer. Diba? Perfect 3-in-1 coffee. Ayan. Okay, how about parts per million or the ppm? Okay? This one class, it's a unit commonly used to express the concentration of a solution, especially for very dilute solutions. Diba kapag very acidic ang isang chemical class, we tend to dilute it. If you can still remember the what do you call this one, the experiments that we have conducted last time. Okay, we diluted some of the chemicals, right? These units are essential for precise solution preparation and reporting in scientific and industrial applications ensuring accurate chemical processes. Okay, so that's all for today's discussion. Thank you so much for listening. God bless on your exam. Galingan nyo po. Make sure that all the things that I have lectured on, the video lecture and our face-to-face, I really hope that those things have been inculcated in your brains. And pagganahin po natin lahat ng ating brain cells para mataas po ang ating exam. Okay? Thank you so much, everyone. God bless.